Hello everybody, I'm Tim Patel. I'm the Technical Marketing Manager for Littelfuse's Electronics Business Unit. Today I'm going to show you some demos that we have here for our Hamlin product line, magnetic sensors being used in a wide array of products, electronics and automotive. Here we have a float level demo. What it has is it has a reed ladder situation in the middle of the column. It contains a series of reed ladders in a vertical orientation and a float magnet that floats at the top level of the water here. Now, every time the float magnet comes into close proximity to one of the reed switches, the corresponding reed switch closes its electrical contacts and actually changes the resistance in the reed ladder. And that's what signifies which light should turn on here. It's really used for level sensing of fluids. At each end of this tube we actually have a float level sensor, or a limit switch if you will. What it has is a little float that actually moves when the water level gets to the bottom of the tube and at the top of the tube. And there's a reed sensor embedded inside of the shaft of the float sensor. And when that float magnet moves to the point of actuation, the reed switch closes and tells the pump here to either start pumping more water or to start pumping out water from the tube, whether it's at the top or the bottom. So it's a very simple demo to show our float level switches and also our reed ladders for level sensing applications. Now, these can be used in a wide variety of electronics. Float switches are typically used in white good appliances like dishwashers or even washing machines. And the reed ladders can be used in a wide array of electronic devices as well. Here we have what's called a speed sensor, and it actually contains two types of Hall effect sensors. We have a transmission here that's simulating an automotive transmission, and each of these sensors actually measures the speed of rotation of a gear tooth here and a magnetically encoded wheel here. This is basically a multipole magnet that has multiple north-south orientations. And as it rotates, this Hall effect sensor will actually pick up the north and south poles. And you'll see a readout here on this computer. You see a pulse wave modulated waveform. That's the signal output. You can use that to measure how fast this transmission is spinning. Now, this gear tooth sensor contains what's called a back bias magnet. Inside of it, there's a Hall effect chip with a back bias magnet. What it does is it orients the Hall effect sensor in such a way that it's close to its activation range. And when a gear tooth actually comes into close proximity to the Hall effect sensor, it actually changes the flux density through the Hall effect chip and actually tells it that there's gear tooth present. When the gear tooth is moving away from the sensor, that flux density changes again, and it tells the sensor that the gear tooth is leaving. You can pick up the leading and trailing edge of the gear tooth to find out how fast the actual rotation is. And again, you can see here, we have a little mock readout of the RPMs. This is also read from the same Hall effect sensor. So it's just another way to use a Hall effect sensor to detect rotational speed. So this can be used in a wide array of automotive type applications, but also for electronics applications. Anything where you have a rotating part and you're interested in knowing how fast it moves. Our demo over here contains another set of Hall effect sensors. These are actually called Rotary Hall effect sensors. They're rotary because they actually detect rotation in a fixed axis. So it's very similar to this automotive application, but this is a little more hands down. You can see the actual output of the Hall effect sensor. What we have here is called a throttle position sensor. So it's used again in automotive applications. And what it has is it's got a shaft with a torsion spring, and the shaft contains a moving magnet. So when I rotate this here, you can see here on this little 3D model, the Hall effect sensor can actually pick up the motion of the sensor in relation to the Hall effect chip. And what it does, it actually changes the flux density again in the chip, and it creates a corresponding voltage output. So you can see on the screen here, there's actually a very fine pitch movement in the voltage range. It really starts from about 0.5 volt all the way up to 4.5 volts. So it's very fine range and very sensitive in terms of the whole 360-degree motion telling you what position in the entire circle the actual magnet is in relation to the Hall effect chip. So this can be used to find out how much throttle is applied to the system. This is a similar type of rotary Hall effect sensor, but in this it's a little different because we have a fixed sensor on one plate here and we have a rotating magnet here. So this is very similar to this transmission demo, but you're actually rotating a magnet in relation to the fixed sensor. And again, it measures the change in the magnetic flux density as the magnet is rotating in relation to a fixed sensor. So again, these two can be used for speed applications, but more primarily for position applications with a very fine pitched output. These are all the demos that we have for our Hamlin sensor products. Of course, we also make other products, so feel free to go to hamlin.com and littelfuse.com to learn more.